Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Welcome. Today we're going to talk about Sir Isaac Newton and Newton's first law of motion, also known as the Law of Inertia. What is a scientific law anyway? A law in science is an idea that stands the test of time, often without change, confirmed by experiments over and over again. You need to remember the scientist and why he is important. Sir Isaac Newton was born in 1642 and died in 1727. Newton established the scientific laws that govern 99% or more of our everyday experiences. From how the moon orbits the earth or the planets orbit the sun, to a hockey puck sliding over the ice, a person riding a bicycle, a rocket that's launched into space. You need to remember that Newton's laws are considered by many to be the most important laws of all physical science. Newton's laws are related to the concept of motion. Why does an object move the way it does? How does an object accelerate or decelerate? To understand these things, we need to understand the relationship between force and motion. Force can cause motion, but what exactly is a force? You need to write this down. We can think of a force as a push or a pull. Force has direction as well as a magnitude or strength. The strength is measured in newtons. A force has direction as well as magnitude as shown in the diagram. A force can be represented by an arrow. Indicating its direction and magnitude tells you the strength and direction of the force. What is the force that eventually stops a ball from rolling? Friction. Friction is the force that eventually stops a ball from rolling across the floor. You need to know that friction is the force of two objects rubbing against each other. Rub your hands together and place them on your face. You can feel that heat is produced by friction. Friction is what will eventually stop an object from rolling. Newton also understood that more than one force can be acting on an object at a time. You need to write this down. The combination of these forces is called net force. Net force is the combination of all the forces acting on an object. There's a force pushing down with 2,500 newtons. There's a force pushing up with 2,500 newtons. The net force of the vertical movement would be 0. There would be no motion. The horizontal forces are 50 newtons to the right and 20 newtons to the left. The net force would be 30 newtons to the right. Again, the net force is the combination of all the forces acting on an object. This tug-of-war example may be on your test. When two forces acting on an object are not equal, we say that they are unbalanced. If the two teams have equal strength, the force that they apply to the rope is equal or balanced, and neither team moves. Write this down. Newton created 3 laws of motion. Today we call them Newton's laws of motion. His first law of motion states that an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. The tendency of a body to resist change in motion is called inertia. Newton's first law is also called the law of inertia. When you're riding in a car with the seatbelt on, the car starts suddenly. You feel the back of the seat push against your back as the car begins to move. This is because your inertia wants you to stay at rest in your original position. But the car is starting to move forward. Since you are held in your seat by your seatbelt, When the car stops suddenly, you move forward because your body wants to stay in motion. If you were not wearing your seatbelt, you would continue with your forward motion and fly through the windshield of the car. The car is providing the on-balance force as it accelerates or speeds up, or decelerates and slows down. Here's another example. What happens when you're riding on a skateboard and the skateboard hits a rock? The skateboard stops, but you keep going. Your inertia keeps your body in motion, but the skateboard was stopped by the on-balance force of the rock. When a book is sitting on a desk, there is no on-balance force acting on it, so it does not move. An object tends to stay at rest. There are forces acting on it. There's gravity pulling down on the book, and there's a table pushing up on the book, but they are balanced, so the book does not move. An object that is not moving is said to be at rest. A chair on the floor, a golf ball on a tee are examples of objects at rest. Newton's law says that an object at rest will stay at rest unless it is acted upon by an unbalanced force. So the chair will not slide until it is pushed. The golf ball will not fly through the air until it is struck by the golf club. The second part of Newton's first law is about objects moving with a certain velocity. These objects will continue to move forever with the same velocity unless an unbalanced force acts on it. Think about driving a bumper car at an amusement park. Your ride is pleasant as long as you are driving in open space. Sooner or later, you are likely to run into another car. Your bumper car stops when it hits another car, but you continue to move forward until the force of your seatbelt stops you. You must remember this. Newton's first law of motion is sometimes called the law of inertia. And inertia is the tendency of an object to resist a change in motion. Mass is a measure of inertia. An object that has a small amount of mass has a small amount of inertia. An object with a large amount of mass has a greater amount of inertia. Therefore, changing the motion of an object that has a small mass is easier than changing the inertia of an object with a larger mass. For example, a softball has less mass and therefore less inertia than a bowling ball. Because a softball has a small amount of inertia, it is much easier to pitch a softball and to change its motion by hitting it with a bat. Imagine how difficult it would be to play softball with a bowling ball. Now we're going to take a look at a demonstration for Newton's first law of motion, or the law of inertia. What do you think will happen to the bear if I place him in the car, put his seatbelt down, send him down the ramp into the stack of books? The bear's inertia is stopped by the force of the seatbelt. Now what do you think will happen when we place the bear into the car without a seatbelt this time, send him down the ramp into the stack of books? Understanding inertia. Look at these two crates. They are the same size. One is empty, the other one has books in it. Which crate has more inertia, and why? The crate with the books has more inertia because it's more massive, and therefore it will be harder to move. The crate with more mass will resist movement than the empty crate. In conclusion, a force is a push or a pull. Friction is the force of two objects rubbing against each other in which heat is produced, like when you're rubbing your hands. Friction is often the force that slows down rolling objects, like a bowl rolling across the floor. Newton's first law of motion is also called the law of inertia. An object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force.
Thank you for joining us on how to improve science performance through strategic note-taking.